Let's talk about single node OpenShift upgrades. So my environment at the moment has an upgrade available to it. So we're going to update that today in this video and see what that looks like. So the benefit for me now that I'm using a single node OpenShift deployment compared to a cluster is that my internet's not great here where I am in Australia. So I'm getting about 30 megabits, 35 megabits per second down, which isn't great. So when I have 5 or 6 instances that are all trying to pull these upgrade images from a remote query registry, that just tanks my internet. It basically becomes unusable and I have to hotspot to my phone to get anything done. So in previous videos, we've looked at using Mirror Registry and the various things that I encountered while using Mirror Registry. But now I'm using single node and it's really a non-event. Like it still pegs my internet pretty hard, but unless you're really trying, you don't really notice it too bad. So let's switch over to the terminal and we will check the upgrade. So you can see here, this is my single node environment and we can see that I have an upgrade available. So 4.15 has a release here. So we're just going to do OCADM upgrade to latest. And now it's requesting the upgrade. And if we get pods in the OpenShift cluster operator namespace, cluster version operator, we got there in the end. Okay. So we can see that it has downloaded a new version. So I've already done an upgrade here. Now in the previous video, I mentioned that I'm using some layering. So I have Tailscale installed on this node. So this is interesting to watch and see what actually happens here and how rpm-ostree rebases on a new image, but keeps my layered installs. So if we follow along with the logs here, so we can follow along with what the cluster version operator is doing to upgrade our single node cluster. And obviously we can do the usual, see get CO to see what's being upgraded and if anything's happening. We can see that the config operator has already changed. It's now 13 days newer. So we'll just leave that running. We see, things are happening pretty quickly here. And that's the benefit of having single node. It just happens so much quicker. So we take a look on my router. We can see here that it's still using fair bit of bandwidth, but it doesn't really impact my ability to use this network. Whereas when I have 5 that are all just absolutely pinning my available bandwidth, that was quite a painful experience. And there was often times where I would start a cluster upgrade and then I would just literally leave the house, which is what I was mentioning in that last video. I like to work remotely anyway. So, go to a cafe or something and hotspot to my phone, have a coffee, come back a few hours later, and I mean like 4 or 5 hours later, and my cluster would be upgraded. Whereas now with a single node, it kind of does it in these bursts, uses quite a lot of bandwidth, but it's not anywhere near comparable to what was happening with 5 nodes, and it was just really making my internet unusable. So go back here. Not sure where it's up to in this upgrade process. Okay, so the API started responding again, so it's clearly doing things for us. So we can see if we grep for 0223. So we've updated the config operator and etcd so far, and it looks like we're doing kube API server at the moment, which is why my API stopped responding, which is obviously the downside to doing single node is you don't have that high availability of your API or your applications because this node will reboot and so will my applications as a result of that. But I think, it's a good trade-off to have something lightweight that's just consuming not a lot of power at all, and it doesn't tank my internet every time I need to do anything. So I think it's a reasonable trade-off for a home lab to have a little high-powered, lots of RAM, single node device running all your applications. Pretty cool. So we can follow along with the node over here on the left side. It's a little bit harder to read because, you never know whether it's an error that you need to be worried about or whether it's just something that happens as a result of the upgrade process. So I like to follow along with it. It's sometimes got some interesting information there, but the key point is like let's not be concerned at this point. There's probably going to be errors as the API drops in and out of availability for a single node. If you're someone who gets worried by seeing lots of errors, it's probably best to just follow along with this one over here for now. So we'll let that run for a bit and we'll come back when it's done. So we take a look at our cluster operators now. we can see that quite a few more have been upgraded at this point. So we're progressing along quite nicely. We haven't had any outages yet. We can see that Unifi, for example, is still up and running. So all of my devices are still connected. So these devices use an inform IP that connects back to an OpenShift route, and that has stayed up. None of the devices have been disconnected. So far so good. So we can see in the Unifi namespace, we have the Unifi notify route. So all of my Unifi devices use this as their set inform address. So we go back here, settings. So we can see there, that's their inform host. So we just set that as an override, and then if you need to log in, you can do the set inform to get them all connected. But yeah, they've stayed connected so far. So we haven't had any actual outages to speak of yet. So we're doing pretty well. But in saying that, the ingress has been upgraded. So, I mean, it might have restarted the pod, but everything seems to have stayed connected so far, which is great. No, it's been up for 83 minutes, so no, it hasn't restarted that pod yet. So, I mean, it's not too bad for a single node. You know, the outage is still minimal. There will be an outage, but it's pretty small. So it looks like we're, you know, most of the way there now. We've upgraded most of them. What have we got left? So just these few left. We'll go back to following those logs and we'll check back when it gets closer to the end. So it looks like we're leaving the machine config to the last thing. So we're going to upgrade everything else. Then we're going to upgrade the underlying CoreOS version. You can see that mostly everything else has been done now. We're doing the console at the moment. Network operator still needs to go. So the network operator there is being upgraded. So checking on Unifi again, we've still got all of my devices connected. No real outages yet. All the devices in my topology are still connected to their access points. This will never change. Even if Unifi goes away, the devices can still connect. So there's no real worry there. It's more that the devices themselves will be disconnected from Unifi, and we might need to reconnect them. So have we started yet? Still haven't started yet. Must still be pulling that pod. Describe pod. Yeah, so it's still just pulling the image. We can see that kind of correlates with our network graph as well. We're pulling 4 megabytes per second. Okay, we've started our network operator now. So we can see that it's going and performing the upgrade of the OVN Kubernetes environment. So the next ones to go will be our machine config. And this is one I really want to look at and go over, what happens from the single node perspective. And this is where we'll start to see the outage as well, particularly with that layered package that we have in Tailscale. Let's see, how it handles that. So if we run a speed test at the moment while it's working on things, let's see what our speed test looks like. So at this point, the upgrade is mostly over and I'm still getting 6.6 megabits per second. So terrible internet. You can imagine what it looks like when we have 5 nodes all at once downloading all of these containers. So we're just waiting for the daemon set and OVN Kubernetes to become available, and then I assume we will get started on the machine config operator. Okay, terminating our OVN pods there, so we're restarting OVN now. Okay, just onto the machine config operator now. So onto our last operator to upgrade. Alright, so we can see the config operator is being created. So obviously we need to create the operator first, and then the operator will have all the information about what needs to happen for the upgrade. And then when this machine config daemon starts to update is when we'll start to see rpm-ostree information pop up over here. So we can see there that it started a version change. So that is what I was talking about, where the operator itself is going to know what's required for the upgrade. So it has recognized that there's a version change now, and it will pull in the new containers that are required. Sometimes there's no change between upgrades. Maybe the machine config daemon didn't change, there was no commits, so it doesn't need to start a new one. But in most cases, it will pull down the new container and start the new container. And I haven't checked, maybe there's no new upgrade to the rpm-ostree version for CoreOS either, but we'll see what happens. So we can see that it has rendered some new kubelet configuration. So those ones were only just created 49 seconds ago. And which that obviously, once you change these, then that turns into a rendered version. I've already made a video on machine config operator though, so if you want more information about that, check out that video. We can see over here on this screen now, it's doing things with rpm-ostree to download the latest version of the rpm-ostree image. So if we do, we can see that there's a transaction in place, so it's rebasing on top of that ostree image. So this is our image here if we wanted to check that out anywhere else. So I'll follow along with those logs and wait for it to finish. We can see all my Unifi devices still online, and we can see this is where it downloaded the network operator, and now it's downloading the rpm-ostree image. So we follow along with the logs of the machine config daemon on this one. We can see that it recognized that it has a custom layer that it needs. So the custom layer 1, and that's just my tailscale package that it needs to make sure is installed when it pivots to the new rpm-ostree image. So you can see the exact command it's running there as well. So it runs the rpm-ostree rebase using the experimental flag onto the image coming from Quay. So again, it's just a waiting game here to see how long it takes to download the image over my internet. Okay, so at the top we can see what rpm-ostree is doing there. So we're downloading a new package for tailscale, and we are enabling repos for cryo and tailscale stable, and then we're going to do an update. So the top is the logs from the CoreOS node itself, the bottom is the logs from the machine config daemon. Okay, so here we can see that it has updated some packages and now it needs to reboot. So we're going to reboot the node, and there it goes, it's gone, the node is being rebooted. So we'll just ping it until it comes back online. Okay, node is back up. So there we go, we logged into the node now. If we do sudo rpm-ostree, remembering we're in a new image now and status, we can see that we still have the tailscale here. This is the one we have loaded into, and this is the old one. So if we needed to pivot back to the old one, we can still do that at this stage. But once the machine config daemon is up and running, it will clear up this old one. So we have a very limited amount of time to make that decision. And it's not something that is automated either, so it would be a bit of a mess if we tried to pivot back to it manually. So we actually looked at doing this manually in one of my previous videos. If you want to check out that video, I'll link that above or wherever it ends up on YouTube. So we can see here that there's some rpm-ostree things that are being run here. And I don't think the API will be up just yet. Oh, it is, it's already up. That is cool. So let's follow the logs of the machine config daemon. And so you can see here that it validates the on-disk state to make sure that it's correct, and it cleans it up here somewhere too. I think we should, oh yeah, there. So running rpm-ostree cleanup-r, so that will get rid of the old image. So we go down here now and do status. We can see we've only got the one image. So yeah, that happens here when it does that cleanup. It will remove that old image. So it updates the annotations for the node, and then it validates that it's correct. So it's completed the upgrade. So let's check out our Unifi pod though. So we can see that Unifi is creating, the database is back up and running. So if we go back to our Unifi window, now if I refresh this now, it'll obviously fail because the container is not up and running. So we need to wait for that container to come back. There's probably a new version available, so this will also update my version of Unifi. We get the deployment there. We can see that what I do with the image, I've got always pull. So every time this pod is deleted, it will always pull the latest version because I just want it to update all the time. So that's a pretty cool thing you can do if you didn't know. You can actually do the logs on the deployment because you don't always know the name of the pod because it has the ephemeral part at the end of it. So we do OC get deployment in the Unifi namespace. We have two deployments and we can see the Unifi DB one is ready. So if we wanted to do OC logs-f deployment Unifi DB in the Unifi namespace, we can see that that will get the logs of the Unifi DB pod, even though the actual name of it is this random thing. I can use the consistent name for the deployment, and it also works with services. So we get a service, we can do OC logs-f -n Unifi, and then we can do it on the service svc Unifi DB. That will also get the logs. So that's a pretty cool way to get logs of something. If you don't want to get the ephemeral name at the end of it, you can just do it on the deployment and that will give you the logs. But obviously if you have multiple replicas, it's only going to give you one of the logs. If you want the specific ones, you would still need to choose the pod. So Unifi is back up and running there now, so we'll bring back our web browser and we'll refresh this. So there we go, we have Unifi back up and running. Now, we've got two devices that have reconnected automatically, so we'll see if these other ones come back up in time. Okay, 3 devices, that's the 24 port switch behind me in the rack. This 8 port switch is in my shed, it connects to the bedroom AP. So my network layout, you can see in the topology, goes the 24 port switch behind me. Then from the 24 port switch, we go into an access point, which is on the shelf behind me, up on that shelf, but you can't see it. We can see the single node OKD device plugged directly into the switch. Then from this access point, we go to my bedroom AP, so that's running in the master bedroom of the house. So it runs from the shed to the master bedroom. And then most of the devices will connect to that. So the only one that hasn't come back online is this AP. So if you needed to fix that manually, if you're not familiar with Unifi, you can log into them. So I logged into that device and you do set inform. Oh, it's actually just come back online, but if you needed to, you do set inform http Unifi notify OKD shift.net /inform, and then that would usually be enough to reconnect it. But they should reconnect automatically because we've got that override in the settings in Unifi. Anyway, that's beside the point of the video. Let's check how this upgrade has gone. So we can see there all of the cluster operators have been upgraded. My node is back online. And we check the application Unifi to see that it's back up and running. So that is how we upgrade the single node OpenShift OKD environment. We can see it's actually quite easy. Even on my slow internet, it upgraded fairly quickly. You can check out the time in the top right hand corner of my screen share if you really want to know how long that took. But you know, obviously there's downsides. We can't have high availability of applications if we only have a single node. It will reboot at some stage, but it did only reboot once. Even when the ingress pod was upgraded, even when the ingress operator was upgraded, we didn't see an outage. We only really saw that one main outage when the node actually rebooted. So it just downloads that rpm-ostree image and pivots over to that image, then reboots, and then cleans up the old one once it's verified that it's functional. So if you want more information about the cluster version operator upgrade process and what it actually does, I've got a video on that. I'll link that. I'll put them in the linked videos in the end card of this video. And then I've also done the machine config so you can see how it does that pivot to the new image. So if you have any questions, let me know. I hope you find single node OKD as useful as I do, because I'm actually quite enjoying it. I'll see you in the next video.